Welcome back, everyone. Today, we're diving deep into Amazon SQS.
Yeah, a service I'm sure many of you use in some way,
Oh, absolutely. But,
at least have heard of.
even for seasoned engineers, I think there's always something new to learn with SQS, especially when you get into the nuances of architecture.
Definitely.
So let's just start with the basics. Like, when we talk about SQS, what are we really talking about? Like, what's the problem it's trying to solve?
I think at the very core, it's about decoupling different components in your applications or system.
Right. Decoupling. So, I've run into situations where, like, that was critical, especially, when you're dealing with microservices or anything that's asynchronous. It's like you need that separation.
Yeah, it's really all about making those connections, but making them flexible, and that's really where SQS comes in. Gives you that buffer, it absorbs those spikes in traffic or load, and it makes sure that if one part of your system goes down or slows down, the whole thing doesn't just grind to a halt.
That resilience, it's so key. Now, of course, the tech landscape, it never stands still, right? There are other messaging services out there, SNS, MQ. Um, how does SQS fit into that bigger picture?
Well, it's like with many things in engineering, the right tool for the right job. SQS is fantastic when you need something simple, scalable, and cost-effective for those high throughput kinds of use cases.
So when you say high throughput, what comes to mind for you?
Well, think about, handling like massive website traffic. You need to process those clicks or requests very quickly, but the exact order they came in might not be the most critical thing.
I see. So SQS, it's like our reliable workhorse for
Yeah.
those background tasks.
That's a good way to put it, yeah.
Okay. So then what about SNS and MQ? When would we pick those instead?
So SNS, it's more about broadcasting. It's like think of it as sending out a notification, and everyone who's subscribed to that topic, they all get it at once.
I see. Okay.
So alerts, updates, anything where you need to fan out that message to many places simultaneously, that's a good fit for SNS.
So SQS is our reliable queue. SNS is like our town crier.
Exactly. Spreading the news far and wide.
Okay. What about MQ?
MQ is all about compatibility. So if you've got a legacy application and it uses these older, maybe more enterprisey messaging protocols like JMS or AMQP, even MQTT, MQ can help you bring that into the AWS world.
Right. So you don't have to rewrite everything from scratch.
Exactly. That's
Yeah.
the key benefit there. Migration without the massive headache.
Makes a lot of sense. Okay. So we've got a good feel for when to use which service. Now let's talk about the core of SQS, the queues themselves. We've got standard queues and FIFO queues. What's the difference? What are the trade-offs?
So with standard queues, the focus is on speed and throughput. They're designed to just get those messages delivered as fast as possible.
But the order might not be guaranteed. Is that right?
That's right. The order they received might not be the same as the order they were sent. If order is absolutely critical, then that's where.
FIFO comes in.
Exactly. FIFO. First in, first out. You're guaranteed that messages are processed in the exact order they arrived in the queue.
Okay, so like processing financial transactions or user commands, anything where that sequence is absolutely critical.
You got it. Those are perfect examples. You wouldn't want to process a withdrawal before a deposit, for example.
Right, that would be disastrous. Now, when it comes to reliability, how does SQS make sure that messages don't get lost, especially in a distributed system?
Well, SQS has a clever trick up its sleeve. When a message is sent to a queue, it's actually stored redundantly across multiple servers. So even if one server fails, your message is safe.
Okay, so that redundancy is baked right in. What happens when a consumer picks up a message from the queue? Is it removed right away?
Not immediately. That's where the idea of a visibility timeout comes into play.
Visibility timeout. Okay, I'm intrigued.
So when a consumer grabs a message, it's still there in the queue, but it becomes invisible to other consumers for a set period of time.
So it's like checking out a book from the library. It's still in the library, but it's not available to anyone else until you bring it back.
That's a great analogy. And this timeout is crucial because it prevents message loss if, say, the consumer crashes or fails to process the message for some reason. If they don't finish processing within the timeout, the message becomes visible again and another consumer can pick it up and try.
I see. So it's like a safety net to make sure those messages don't just disappear. But setting that time out, it sounds like a balancing act, right?
Yeah, you hit the nail on the head. If it's too short, you risk processing failures. But if it's too long, you might be tying up resources unnecessarily. Finding that sweet spot is really important.
And I imagine that sweet spot, it depends a lot on the specific application, right?
Absolutely. How long it takes to process a message, what your retry logic looks like, the impact of delays on your system, all those factors play a role.
So no one-size-fits-all answer there. It's all about those trade-offs. Okay, this is getting really interesting. Now, I've heard about long polling in SQS. What's that all about?
Long polling is this neat technique that can help reduce costs and make your queues more responsive. Instead of constantly checking for new messages, consumers can wait for a specified period.
So instead of running back and forth to the mailbox every minute, you just wait patiently for the mail to arrive.
Exactly. It cuts down on those empty responses, fewer API calls, lower costs. Everybody wins.
Love it. Those small optimizations that can make a big difference in the long run. Okay, we've talked about queues, messages, timeouts. What else should we know about the actual messages themselves in SQS?
One thing that often gets overlooked is message attributes.
Message attributes, like adding a little sticky note to the message with some extra information.
That's a great way to think about it. They let you add metadata to your messages, making your messaging system more intelligent.
So for example, if we're processing a video upload, we could use attributes to store things like the video format, the resolution.
Exactly. Or even user-specific preferences.
So much potential for filtering, routing, triggering actions based on the content. That's powerful.
Yeah, it adds a lot of flexibility. But just remember, there's a limit on attribute size, so use them wisely.
Right. Don't want to overload those messages. Now, thinking about standard queues, especially those with a high volume of messages, is there a limit to how many messages can be in flight at once?
That's a really important question, especially in high throughput scenarios. Typically, for standard queues, you can have about 120,000 in-flight messages at any given time.
120,000. That sounds like a lot. But I can imagine that for some systems, it might not be enough. What happens if you hit that limit?
Well, if you're consistently hitting that limit, it's usually a sign that your consumers aren't keeping up with the influx of messages. It might be time to scale up your processing or look for ways to make your message handling more efficient.
Like monitoring the traffic on a highway. If you start seeing congestion, you either need more lanes or got to find ways to make the existing lanes move faster.
Exactly, that's a perfect analogy. And another crucial point is to make sure you're deleting messages promptly once they've been processed.
So it's like cleaning up those finished dishes so you can keep cooking and serving more meals.
You got it. Keeping those in-flight messages under control is all about maintaining that smooth flow.
This has been a fantastic deep dive into the fundamentals of Amazon SQS. I feel like we've covered so much ground, and yet I know we've just scratched the surface.
Oh, there's so much more to explore. And in the next part, we're going to delve into some of those advanced features that SQS has to offer.
Oh, I'm ready for more. What secrets are you going to reveal?
Well, next time, we'll dive into things like dead letter queues, high-throughput FIFO queues, and even touch on server-side encryption.
Sounds amazing. I can't wait to unlock those advanced features. Stay tuned, everyone, because our deep dive is just getting started. We'll be back soon with part 2. Welcome back, everyone. Last time we really dug into those foundational concepts of Amazon SQS, but now I'm ready to level up. Let's talk about some of the advanced features that really make SQS shine, especially for, well, demanding applications.
You got it. There's a lot more to SQS than meets the eye, and these features can be real game changers when you're building complex systems.
I'm particularly curious about dead letter queues. The name sounds a little ominous, I have to admit.
Yeah, it does, doesn't it? But
Uh,
they're actually incredibly helpful. Think of them like a safety net for your messages.
A safety net, okay. How so?
Well, imagine you have a message that keeps failing to process. Maybe there's a bug in your code or a server that depends on is down. Without a dead letter queue, that message would just keep retrying in your main queue.
Right, and potentially causing a bottleneck, I imagine.
Exactly. It could block other messages and cause all sorts of problems. But with a dead letter queue, or DLQ for short, that problematic message gets redirected to a separate queue.
So it's like having a special holding area for those troubled messages.
That's a good way to put it. And this lets you isolate those messages, analyze them, figure out what went wrong without disrupting the flow of your main queue.
Makes sense.
Yeah.
So we can examine them, see if we can fix the issue, and maybe even retry processing them later.
Exactly. Or you can use the DLQ for logging and monitoring. It's a great way to track down those persistent errors and improve the reliability of your system.
Dead letter queues sound like a must-have for any serious SQS implementation. Now, you mentioned high-throughput FIFO queues last time. I'm really intrigued by those.
Oh yeah, they're pretty cool. Regular FIFO queues guarantee message order, but they might not be the fastest when you're dealing with really high volumes of messages.
So how do high-throughput FIFO queues address that?
The secret is partitioning. They divide the queue into multiple lanes, each capable of handling messages concurrently. This dramatically increases the number of messages you can process per second.
So it's like going from one checkout lane at the grocery store to having multiple cashiers. You can process more customers without sacrificing the order of people within each line.
Exactly. And here's the really clever part. Messages within the same message group are always processed in order, even if they're spread across multiple partitions.
Message groups. Okay, I'm following so far.
Think of a message group as a way to bundle related messages together. Let's say you're processing a series of user actions. You can group those actions together, and they'll always be processed in the right sequence, even with all that partitioning going on.
So even though we're processing things in parallel, we still maintain that fine-grained control over message order. Very cool.
It is, and the performance gains are huge. We're talking tens of thousands of transactions per second. This opens up a lot of possibilities for applications that need both high throughput and strict message ordering, like real-time data processing or high-volume financial transactions.
That's some serious power. Okay, we can't talk about modern systems without addressing security. How does SQS help us keep our messages safe, especially when we're dealing with sensitive data?
Security is absolutely paramount, and SQS has some robust features to protect your data. One of the key ones is server-side encryption, or SSE. With SSE enabled, your messages are encrypted the moment they arrive at the queue and stay encrypted until they're delivered to an authorized consumer.
So it's like having those messages locked in a vault while they're waiting in the queue. Only the right key can unlock them.
You got it. And for even more control, you can manage your own encryption keys using AWS KMS, the key management service.
Ah, so you're not relying on AWS to manage those keys for you. You have full control.
Exactly. That's essential for meeting those strict compliance requirements in certain industries.
Right, especially when you're dealing with sensitive data. Managing your own keys provides that extra peace of mind. What about access control? How do we make sure only the right users and services can interact with our SQS queues?
That's where IAM comes in, AWS Identity and Access Management. IAM lets you define very granular permissions. You can control who can send messages, receive messages, manage queue attributes, even delete queues.
It's like having different levels of security clearance, making sure that only authorized personnel can access specific areas or information.
Exactly. And to enhance security further, consider using VPC endpoints. They let you access SQS resources from within your VPC without going over the public internet.
Like a private tunnel directly to our SQS queues.
You got it. No eavesdroppers allowed.
These advanced features and security considerations really show how powerful and sophisticated SQS is. It's clearly much more than just a simple queuing service.
Absolutely. There's a lot going on under the hood, and understanding these features can make a huge difference in how you design, build, and operate your systems.
Okay, so we've covered some powerful tools for architects and engineers to build secure, robust systems. What's next on our SQS journey?
Well, in the final part, we're going to shift our focus to the operational side of things. We'll explore techniques and features that can help you engineers fine-tune your SQS implementations for optimal performance and efficiency. Things like message timers, batching, and how to keep a close eye on your queues using CloudWatch metrics.
Sounds like we're about to get into the nuts and bolts of making SQS really hum. Can't wait. Stay tuned, everyone. We'll be back soon with a final part of our SQS deep dive. Welcome back, everyone. We've explored the core concepts of Amazon SQS, uncovered those powerful advanced features, and even ventured into the realm of security. Now it's time to shift gears and focus on optimizing our SQS implementations for maximum performance.
Yeah, let's get into those operational insights and techniques that can really help you fine-tune your SQS setup.
All right, I'm ready to get my hands dirty. Let's start with message timers. I know they can be really useful for things like scheduling tasks and retry logic, but I'm a bit fuzzy on how they actually work.
Sure. So message timers give you this fine-grained control over when a message becomes visible in the queue.
So it's like setting a snooze button for your messages.
Exactly. You can delay processing for a specific period.
Mhm.
Imagine you have a process that depends on data from another system, and that data gets updated every hour. You could use message timers to hold those SQS messages until after the data refresh.
Ah, so we're not constantly polling for data that might be outdated. We're syncing up with the data source.
That's right. And it's also really handy for retry logic. Let's say a message fails to process because a downstream service is having a hiccup. Instead of immediately retrying and potentially making things worse, you can use a timer to delay the retry, give that service a chance to recover.
Okay, that makes a lot of sense. So we're giving that service a little breathing room to get back on its feet. Are these timers applied at the queue level, or can we set them for individual messages?
You have flexibility there. You can set a default delay for all messages in the queue, but you can also override that for individual messages if needed. There's one little quirk, though. FIFO queues don't support timers on individual messages. It's a trade-off for maintaining that strict order.
Got it. So if we need both per message delays and guaranteed order, we might have to stick with a standard queue. Okay, let's move on to batching. I know it can really boost performance, but how does it actually work in practice?
Well, batching allows you to send and receive multiple messages in a single API call.
So instead of making a separate call for each message, we can group them together.
Exactly, and that reduces the overhead significantly. It's like taking a bus instead of individual cars. You're moving more people with fewer trips.
Right. Less back and forth, more efficiency.
Hmm.
Are there any best practices for batching? How do we figure out the right batch size?
Well, the optimal batch size depends on a few things: message size, desired throughput, latency requirements. It might take a bit of experimentation.
So we start with a reasonable size and then tweak it based on our performance metrics.
That's the idea. Find that sweet spot that balances throughput and latency.
Got it. Now, with all this activity happening in our queues, how do we keep track of everything? How do we know if things are running smoothly?
That's where CloudWatch comes in. It's our go-to tool for monitoring
So
SQS.
it's like a dashboard for our queues.
Yeah, you can think of it that way. It gives you all sorts of metrics: number of messages in the queue, age of the oldest message, number of messages sent and received, even the size of your messages.
So we're not just looking at the volume of messages, but also their characteristics and how efficiently they're being processed.
Exactly. And those metrics can help you spot potential problems early on. Like if you see a consistently high number of messages in the queue, it might mean your consumers are struggling to keep up.
Ah, so it's like those little warning signs that can help us prevent small issues from becoming big problems.
That's right. CloudWatch gives you the visibility and data you need to make smart decisions about scaling your resources, optimizing your code, and just generally keeping your SQS implementation running smoothly.
This deep dive into Amazon SQS has been incredible. We've covered so much from those foundational concepts to advanced features, security-based practices, and now these operational insights that can really make a difference.
It's been a pleasure sharing this knowledge with you and our listeners. SQS is such a versatile and powerful service. The more you understand it, the better equipped you'll be to build those amazing systems.
And I think this deep dive has given everyone a great foundation to build upon. Whether you're designing complex architectures or optimizing existing systems, there's something here for everyone.
I completely agree. And the learning never stops. Keep exploring, experimenting, and pushing the limits of what's possible with SQS. The AWS community is a fantastic resource for sharing knowledge and learning from each other.
Couldn't have said it better myself. A huge thank you to all our listeners for joining us on this deep dive into Amazon SQS. Until next time, happy building, and may your queues always be flowing smoothly.